Hello, family. Welcome to another session of Maths Fanatics 24/7. In this video, we're going to be looking at probability, permutations, and a tree diagram question. Okay, so ladies and gents, if you are in grade 11, you can skip question 11 because it's on permutation, which is examined only in grade 12. But if you're curious, you can still watch it. But if not, you can just skip the video until question 12. Okay, perfect. So on question 11, we are given the digits. How many digits? Let's see. 1, 2, 3, 4, 5, 6, 7. So which means we have 7 options. Ne? So the amount of things given is your options, basically. Ne? Perfect. And then before I even read the question, I know this. Ne? If repetitions are allowed, repetitions, right? Option stays the same. Ne? So your options will always be 7. But if there's no repetition, the next position will be 1 less. So your options are going to reduce by 1 all the time. Does make sense? So here, the options reduce by 1 each time. Ne? Each time. Okay, this is what I know. Awesome. And then now we're going to do 11.1. Ne? Calculate how many unique 5-digit codes. So we need to create a 5-digit code. 1, 2, 3, 4, 5. Can be formed using the digits above if the digits may be repeated. So repetition is allowed, right? So if repetitions are allowed, the option stays the same. So I can have a code that is 9999. Can have 8888. So the options will always stay the same. So here I have 7 options to pick, 7 options to pick, 7 options to pick, 7 options to pick, 7. Then you multiply that, which is basically 7 to the power of 5, right? When we press it on a calculator, it's going to simplify to 16807. Then that's finito. Okay, awesome. So we're going to go to question 12 now. Okay, on question 12, 12.1, we are given probability of A. We are given probability of B to be Y. We are given the probability of A or B. Then we are asked to find the value of Y. Ne? If A and B are mutually exclusive. Remember, mutually exclusive, I know that PA and B is equals to 0, right? Because they are mutually exclusive, it means they cannot occur at the same time. So their probability is 0. Okay, and then if I see the OR, there's only one formula that has the OR in it, which is PA or B. It's PA plus PB minus PA and B, right? I'm sure you have seen the video where we discussed all the formulas. If you haven't seen it yet, it's the first video in this folder, in this playlist. Please watch it. It's going to be helpful in this type of questions. Okay, perfect. Now we're going to substitute PA or B is 0.74. Then PA, 0.45. PB is Y minus PA and B, it's 0, right there, because they said mutually exclusive. Okay, so I have 0.74 minus 0.45 equals to Y, right? Therefore, Y must be equals to 0.29. Ne? So it must give us 0.29. If you press it on a calculator, it should give you 0.29. Okay, perfect. Ladies and gents, I'm so sorry about this, I think I skipped some few questions on 11.1. I think I skipped some few questions on 11.1. So I'm going to quickly go do them. I'm really sorry about that. So let's see here. Let me just clear all. Okay. Because here I'm realizing that I covered this part here, you see? Okay. So ladies and gents, I'm sorry. We're just going to finish this quickly and then we'll go back to 12.2, 12.2. So here we already have the answer, so we're fine, okay? Awesome. So we'll go to, okay, let's see now. Let's finish these questions quickly. Okay. This one was answered, right? Then this one, they said digit may not be repeated. Remember, we have 5 options. So I have 7 options. Then if there's no repetition allowed, the number of options reduced by 1 all the time. I'm sure you put this in your note somewhere. So I'm going to have 6, 5, 4, and 3. Then you multiply them together, right? And that should give you 2520 when you press it on a calculator. Okay, perfect. Then now we're going to 11.2. Okay, so on 11.2, they say, how many unique 3-digit codes? Okay, so 3 digits, ne? Sharp, can be formed using the above digits. Remember, we have 7 options. 7 options, which was, let's go check quickly, what are they? So I'm just gonna write them down here. Let's write them down, these options. I have 3, 4, 5, 6, 7, 8, 9. These are my options, which are 7 in total. Okay. Then they want me to create a 3-digit code. Okay. That can be formed using the above digits. If digits may be repeated. Okay. Digits may be repeated. I know that where there's no condition, the options are always going to be 7. Okay. Sharp. The code is greater than 4,000. Okay, so for it to be greater than 4,000, but less than 6,000, it means it can only start with 4 or 5. So here I'm going to start with either 4 or 5, right? Sharp. And then the code is divisible by 5. So for it to be divisible by 5, it must end with a 5 or a 0. But in this case, we only have a 5. So it can only there. And then I can start with a 5. I can also end with a 5 because repetitions are allowed. And then here, there's no condition. So I'll always, where there's no condition, you just put 7 because repetitions are allowed. Ne? Then you count the options that you have. So here I have 1, 2. So I have 2 options there. Here I have 1 option. Then you multiply them. And then this should give you 14. Ne? So, and then this is the answer to this question. Okay. Perfect. I hope that makes a lot of sense. Now we're going to move to question 12 again. Okay. So let's go to question 12. Okay, we don't need this. Let's take it down. We don't need that. We don't need that. We don't need that. Sharp. Where's our question 12? Sharp. So on question 12, right? They say an organization decided to distribute gift bags of sweets to grade R class at a certain school. Okay. There is a mystery gift in exactly 1/4 of the total number of bags. Okay. So there's mystery gift. Okay, sure. Each learner in the class may randomly select 2 gift bags of sweets. Right. One after the other. The probability that a learner select 2 bags of sweet with a mystery gift is that. Ne? Perfect. Calculate the number of gift bags of sweets with mystery gift inside. Okay, so this is a 3-diagram question. So a learner, they say what? Each learner in the class may randomly select 2 gift bags of sweets, right? Sharp. So this is there. Then one after the other, right? So there's a gift bag, right? And then there's a bag that has mystery gift. Ne? So I'll just call it M. Ne? Perfect. And then we're going to do this now. Let's see. Okay, so here I'll just say sweets, ne? Then this one is mystery gift. I'll put G there. Sharp. Remember the learner is selecting how many times? They are selecting twice, right? Sharp. So I'll say GS and then MS for mystery, ne? And then GS and then MS there. Sharp. Now we need to put probabilities here, right? So they say there is a mystery gift. The probability is there. Ne? So the probability is 1/4, right? So obviously for the total probability to be 1, this must be 3/4. But this is already simplified. Ne? So I'm going to introduce X here, the proportionality constant X. Ne? Sharp. So which means the total amount of sweets that I'm going to have is that, ne? The total amount of bags basically. It's 4x. Okay, perfect. And then now here, let's do the totals quickly. Show you something here. So the total was 4x, but we're going to be 1 bag short. So the total will now become 4x minus the 1 bag that we took there. 4x minus the bag that we took there. So the total must be the same across here, basically. Ne? 4x minus 1. Sharp. So here, we firstly selected this part, right? So I'm going to have 3x and then I minus 1 because I selected that part. This part will remain the same because I didn't select M there. So the M will remain the same, right? And then this part here, it means I started with M. So whatever was M will be 1 short now. So 1x minus 1. And then whatever was not M will be the same, which is 3x, right? Awesome. And then now they say, let's check this part. The probability that Elena selects 2 bags of sweet with a mystery gift is that. Ne? So basically, both mysteries that. So we are given this line here. Ne? So they say if I multiply these 2 probabilities, basically, my answer must be that. So I'm going to do that there. 7/118 equals to 1x over 4x. Then I'm going to multiply by x minus 1/4x minus 1. I didn't put the 1 here because we know that there's a 1 there. So this x will cancel that x, right? And then basically I have 1/4 here. So I can divide this side by 1/4. Divided by 1/4 gives me x minus 1/4x minus 1. Let's see what answer do we get there, right? Okay. So here we have 7/118 divided by 1/4, which is 14/4. 59 is equals to x minus 1 over 4x minus 1, right? And then from here, I'm going to cross multiply. I'm going to cross multiply. So this 14 will multiply this bracket. Then the 59 will multiply that bracket. So I have 14, 4x minus 1 equals to 59 x minus 1. Then what is 14 by 4? Let's check on our calculator. 14 by 4. 14 by 4 should be 56, okay? I'm getting 56, so it's fine. So here I'm gonna have 56x minus 14. Here I'm gonna have 59x minus 59, right? Then I'm gonna take the 59 that side and then the negative, the 56x that side. So this is going to be positive 59 minus 14 is the same as 59x minus 56x, right? Then 59 minus 14 should give us, let's see, 45. And then here we have 3x, then divide both sides by 3. Therefore, x equals to 50. And then this is what? This is our final answer in this case. That makes sense. So there are going to be 15 what? 15 gift bags of sweet mystery, right? Because you can see here that it's x. You see 1x, and then it goes with that. If they said the other sweets, we're going to say 3 times x, which is 45. Okay, ladies and gents, if this makes sense, please don't forget to hit the subscription button and share with family and friends. I hope to see you soon in other sessions of Maths Fanatics. They will keep on coming. They will keep on coming. Thank you very much. Tanko. A luta continua.